Graphing quadratics in factored form. Okay, the first form of quadratic functions you learned about was called standard form, written in the form of f of x equals ax squared plus bx plus c. The second form of quadratic functions is called vertex form, written in the form of f of x equals a parentheses x minus h squared plus k. And the third and final form we will learn is called factored form. Okay, so this is factored form. It's written as a parentheses x minus r sub 1 times parentheses x minus r sub 2, where r1 and r2 are the roots, right? And roots is just a synonym for x-intercepts, okay? So what's great about the factored form is that it tells you where the roots are. It's the opposite, because it's got that minus in front of it, right? It's the opposite of this number here, and then the opposite of that number there. Those are the roots, okay? So that's what's great about factored form. So kind of some of the other notes, what happened there? Some of the other notes for factored form. Now, y-intercept doesn't change when we're dealing with this method. We're just plugging in 0 for x. For the x-intercepts, like I just said, it's given in the equation. It's the roots. Now, the axis of symmetry is not bad because it's located right in the middle of the roots. And if you need a formula for it, you can just add the roots and divide by 2. That's going to be, the middle of the two numbers. If you ever want to find the average or the middle of two numbers, you add them and divide by 2. And then the vertex, like always, like in standard form, you're going to plug in the axis of symmetry. So let's get started on this. First, I'm going to do the roots, okay? So the roots, it's the opposite of these numbers in here. So the roots, the x-intercepts, we would have -3, because that said +3, so opposite, and then +5. So it's the opposite of what's in the parentheses, which is similar to the vertex form. So -3 is one of the roots, and then +5. Now, next thing for this graph, what I want to get, I want to get the axis of symmetry. And this is a choice, but I want to get the axis of symmetry. And for a parabola to be symmetrical, the axis of symmetry has to split it, right? It has got to be in the middle of the root. So I can just eyeball this. I know it's going to be at 1. So the axis of symmetry is at x equals 1. That's where the axis of symmetry is. And if you can't eyeball it, remember, it's just in the middle of the 2 points. So what you could do, you don't have to write this one, I'm about to write in blue. You could do -3 plus 5 divided by 2, which would be 2 divided by 2, which is 1. So if you can use that sort of concept as well, if you're trying to find the middle of 2 points or the average of 2 points, you add them up and divide by 2. Okay. And the vertex we know is in the middle. Sorry, that's not what I meant to say. The vertex is on the axis of symmetry, right? So I know that the vertex is going to be somewhere on that blue dashed line where x equals 1. So I'm going to substitute 1 into the equation to find the y coordinate. So here we go. I'm going to go -2, 1 plus 3, 1 minus 5. So I'm substituting 1 into the equation. 1 plus 3 is 4. 1 minus 5 is -4. -2 times 4 times -4, that would be +32. So that means the vertex is at 1, 32. So I just substituted in the axis of symmetry to figure out where on the axis of symmetry that vertex is. So it'd be up here at 32. All right. So I got all those, and I already know what my parabola is going to look like. It's going to open down, right? And that makes sense because the leading coefficient was -2. It's going to open down. But let's just plot one more key feature. Let's get the y-intercept. And the y-intercept, with all these forms, you just plug in 0 for x. That'll always tell you your y-intercept. So -2, 0 plus 3, 0, subtract 5, 0 plus 3, that'd be -5. Multiply those all together, that would be 30. So the y-intercept is at 0, comma 30. So here. And then when I draw my parabola, I've done this before, but I like to draw a little symmetrical point. So I'm going to put a, whoops, what the heck? I'm going to put a little point here. Okay, and there we go. There's a little sketch. All right, let me show you another. Same thing. I always like to find the roots first. So it's opposite of this, opposite of this. So it's going to be positive 1 and positive 7. Opposite of those. So positive 1 here, and then positive 7 here. So those are my roots. Now the axis of symmetry goes through the middle of the root, so I know it's going to be at 4. So the axis of symmetry is at x equals 4. And if you know, if you can't see it, remember you can do just 1 plus 7 and divide that by 2, which would be 8 divided by 2, which equals 4. So if you'd rather do it algebraically, you can do it that way. To find the vertex, remember the vertex is on the axis of symmetry. So we can substitute 4 in for x in the equation to find the y coordinate of the vertex. Whoops. 4 minus 1 is 3. 4 minus 7 is negative 3. Geez, a lot of 3's here. 3 times 3 is 9. 9 times negative 3 is negative 27. So the vertex is going to be located at 4, comma, negative 27. Which would be down here. So we got a nice parabola. It's going to open up, which makes sense. The leading coefficient is 3, positive 3. Let's get the y-intercept. Now, I know the y-intercept is going to be somewhere over here, right? It should be up there if I kind of drew a parabola. It's going to be up there. But let's find the exact location by substituting 0 in for x. So it's going to be 3, 0 minus 1, 0 minus 7, negative 1, negative 7. Multiply those all together, positive 21. So the y-intercept would be at 0, comma 21. So about here. Let me draw a little symmetrical point to that y-intercept about there. And now I can draw a nice, pretty parabola. So that's how you do it. That's how you can graph equations written in factored form. It's great because it tells you what the roots are. So the roots are really quick to get. And just always remember, the axis of symmetry is going to be in the middle of the roots. And you should be able to get a nice curve based off of just that information there. So I'll let you do the rest of those.